Okay, y'all, today we're going to learn how to find the greatest common factor of monomials. Now, you have done greatest common factor, done prime factorization before. I think in 6th grade and 5th grade, you learned how to make a factor tree. So if you were trying to write the prime factorization for 98, you would reduce it down to multiplying with prime factors. You can say it's 2 times 49. 2 is a prime number. 49 is 7 times 7. So the prime factorization of 98 is 2 times 7 times 7. Or some of you may have learned the ladder method. And that's when you just keep dividing by prime factors. And you end up getting the same answer. And we use the factor trees or ladder diagrams to get the prime factorization to help us find the greatest common factor of numbers, or the biggest number that will go into both numbers. So if I took all the factors of 12 and listed them out, they're 1, 2, 3, 4, 6, and 12. And then the factors of 32 are 1, 2, 4, 8, 16, and 32. The greatest common factor is the biggest number that is in both of the lists. So if we were trying to figure out what the greatest common factor of 160 is, we would say, okay, 100 is 2 times 50. That's a prime number. 50 is 2 times 25. That's a prime number. And that's 5 times 5. So our prime factorization is, let's get this down, 2 squared 5 squared, or 2 times 2 times 5 times 5. Now to do the number 60, we would say, okay, that could be 2 times 30. 2 is a prime number. 30 needs to keep going. 5 times 6. 5 is prime. 6 is 2 times 3, and both of those are prime. And so when I list them under here, so this is the prime factorization for 100. This is a prime factorization for 60. It is 2 times 2 times 3 times 5. I can circle the common factors. Each of them have that 2, each of them have a second 2, and each of them have a 5. And then multiply those. 2 times 2 times 5 is equal to 4 times 5, which is equal to 20. The greatest common factor of 160 is 20. Now, this is a method you only need to use if you don't know it or if you can't figure it out in your head. And a lot of you, I know, are able to do that. So we'll do one other example. 26, the prime factorization is 2 times 13. Both of those are prime. 52 is 2 times 26. That becomes 2 times 13. And so to find the greatest common factor of these two numbers, list the prime factorization, and then circle the common ones and multiply. This would be 2 times 13, which is 26. The biggest number that goes into both 26 and 52 is 26. Okay. Now, sometimes we'll need to find the greatest common factor of monomials. And so you can see that on this one, the first thing we would do is find the greatest common factor of 18 and 27. And you guys can probably do that in your head. The biggest number that goes into both 18 and 27 is 9. But you can see here's a g squared, and here's a g cubed. And so the biggest number that goes into both of those is g squared. So the greatest common factor of 18g squared and 27g cubed is 9g squared. Now, You can have a number like this. This is a monomial 8x and another monomial 7v2. The greatest common factor of 8 and 7 is 1. The greatest common factor of x and v squared is also 1. So there is no other number besides 1 that will go into both of those monomials. Now we get to one like this. We have 3g cubed h cubed, and we have 9g cubed h cubed. And so the biggest number that goes into both of these, first we'll check out this. The biggest number that goes into both 3 and 9 is 3. And then you'll see that g cubed is in both of them. And you see that h cubed is both of them, is in both of them. So the greatest common factor of those two monomials is 3g cubed and h cubed. Here's another example. The greatest common factor of this, first check out the 4 and the 8, and the biggest number that goes into both 4 and 8 is 4. Now, there's an s here, but there's no s here. There's a t cubed here, no t cubed here. None of these are in here. So the greatest common factor of those two monomials is 4. All right, and for this one, you can see that the biggest number that goes into both 6 and 8 is 2. Here's x to the 4th and here's x to the 5th. So the biggest number that's going to go into both of those is x to the 4th. Here's y cubed and y squared. So y squared will be the biggest that can go into both of those. And this is z squared, and that's just z to the 1. So z is the only thing that will go into both that and that. And so this ends up being the greatest common factor of both of those monomials. So you just break it down into pieces. Let's look at our next example. Oh, so now we're going to learn how to factor polynomials using what we just learned. We're going to remember the distributive property states that a times b plus a times c can be written like this because we distribute that a to the b, you get an a and you get an a. And when you multiply that out, that ends up being ab plus a times c. And so we're going to use this a lot when we factor this polynomial. So for example, we're going to be looking for the greatest common factor of 2x squared and negative 4. So first I'm just going to look right here. I see that that's a 2 and that's a negative 4. So the biggest number that goes into both of those is 2. What would I multiply 2 by to get 2x squared? I would multiply it by x squared. What would I multiply 2 by to get negative 4? I would get a negative 2. And so if you multiply this out, you're going to get the same thing you got up here, 2x squared minus 4. So I have just factored this out into 2x squared minus 2. I just factored out that polynomial. So on this one, I have actually 3 terms. So I'm going to look for what is common in all 3 of these terms. What's the greatest common factor? And I see that there's a 4 at least in each of those terms. And then I also see there's an x in all of them. And the lowest exponent on the x is a 1. So I can factor out a 4x in each of these terms. So now, in this first place, what would I multiply 4x by to get 8x cubed? Well, 4 times 2 is 8. And then since I'm adding the exponents when I multiply, I need an x squared right here. And that's going to get me that first term. The second term is 4x squared. So what would I multiply that 4x by to get negative 4x squared? And I know this will be a negative then. And all I will need right here is an x, because 4x times this negative x right here will give me negative 4x squared. And finally, I come to the last term. What would I multiply by? I see this is a negative, so I know my negative is going to go here. 4x times what will get me negative 16x, and this is a negative 4. So if I multiply 4x times 2x squared minus x minus 4, I'm going to get the same polynomial that I started out with. You can see that 4x times 2x squared right here is going to be 8x cubed. 4x times negative x is negative 4x squared. 4x times negative 4 is going to be negative 16x. I get the same polynomial I started with, so I know I factored it out correctly. All right, so for this one, I see a lot of negatives. I see that each of my terms have an x in them, so I need to find the greatest common factor of negative 14 and negative 12, and that's going to be negative 2. I also see that there's an x in each one of these, at least one x, so I'll make that be negative 2x. What would I multiply negative 2x by to get negative 14x? And that would be 7. And then right here, what would I multiply negative 2x by to get negative 12x squared? And that would be a positive 6x. So if I multiply this back out, negative 2x times 7, negative 14x, negative 2x times 6x is a negative 12x squared. And I got the same thing I started with, so my work is correct. Okay, and just make sure when you factor out a negative anything in this first step, you do it to the second one as well. All right, on this one, 3x cubed plus 2x squared minus 10. I'm trying to see if there's anything that goes into all of these terms, and I don't see anything. So this one, you would just leave alone. That's like saying, how can you simplify this fraction right here? And you can't. And so you can't factor out anything else in that polynomial. So we'll move on to the next one. We'll go to 9d squared minus 8 squared. And again, I'm trying to find something that's common in both of these, and I don't see it. So you know the answer to this one is to just rewrite the polynomial. Moving on, negative 18y cubed minus 7. So I see that there's a negative here and a negative here. So I'm going to factor out negative. And then there is no greatest common factor other than 1 for 18 and 7. But I do see that there's a y cubed and a y squared here. So the greatest common factor is negative y squared. What would I multiply that by to get negative 18y cubed? Well, all I would need to do is multiply it by 18y, because negative y squared times 18y gives me negative 18y cubed. And then negative y squared, what would I multiply that to get negative 7y squared? Well, it would be a positive 7. Be super careful here. See, this negative times this positive is what will land you with that negative. And so that is that polynomial factored out. Let's move to the next one. This is 8x to the 4th plus 4x cubed minus 2x squared. So I see that there's at least an x squared in every term. So I'm going to put x squared right here. And then I see that's an 8 and a 4 and a 2. So the greatest common factor is going to be 2x squared. Now, what would I multiply 2x squared by to get 8x to the 4th? Well, 2 times 4 is 8. and then x squared times x squared is x to the 4th. I see this will be a plus sign here. So I know 2 times a 2 is 4, so I'll put that there. And then x squared to get to x cubed is just an x. And then what would I multiply 2x squared by to get negative 2x squared? And that's just a negative 1. Okay, and here we have a little word problem. This says the area of a court for the game squash is 9x squared plus 6x meters squared. So don't get this confused as being part of the polynomial. That's the unit of measure. That's the unit of measure. So I'll just write that there so we're not confused. That's not part of the polynomial. Factor this polynomial to find the possible expressions for the dimensions of the squash court. So here's our squash court, and the area is 9x squared plus 6x. So L times W will give me that area. Or in other words, this, whatever this is, times whatever this is. And how can I figure that out? Well, I'm going to look for the greatest common factor in 9 and 6. That's 3. And then there's also a 3x in there. What do I multiply 3x by to get 9x squared? That's another 3x. What would I multiply 3x by to get 6x? And that would just be a plus 2. So what that tells me is the width of this is 3x. And the length of this is 3x plus 2. Those could be the possible dimensions. That's all that question's asking. Okay, sometimes when we are factoring out a polynomial, we are going to pull out a common binomial. In other words, there are 2 terms in there. So I see in this whole expression right here, this and this they're binomials and they're the same. So I'm going to pull that out, x plus 2. And what would I multiply that by to get this and this? It would be 5 plus 3x. That's what's left over when I pull this out. So I'm going to multiply this, x plus 2 times 5. Guess what I'm going to get? 5 times x plus 2. Then I'm going to multiply x plus 2 times 3x. And what I'll get is 3x times x plus 2. And so this next one's done the same way. I'm going to pull out these 2 binomials. They're the same. B squared plus 1. And then I'm going to multiply that by negative 2b. And then, I just need to get the same thing here. So what would I multiply this binomial by to get the same thing, to get itself? And that's just going to be a 1. Here's another example. You can see this binomial is the same and this binomial is the same. So we'll pull those out, x plus 6. And what I have left is this, 4s minus 5. All right, I bet you're getting the hang of it. Now let's do this one. We'll pull this binomial out because they're the same, 2x plus 3. And I'm going to multiply that by 7x. And what's the coefficient right here, even though you can't see it? Plus 1. Okay. And then sometimes we just need to recognize that opposite binomials can help you when you factor polynomials. We're not going to get into it a lot today, but just know that this 5 minus x and x minus 5 are opposites, and you can rewrite 5 minus x as negative 1 times x minus 5, because look what happens when you do that. When you distribute this negative 1 to that and to that, what you end up with is negative x plus 5, which can be rewritten as a positive 5 minus x. Notice the signs in front of each of these terms are the same as they are up here. That's a positive 5, that's a negative x. So 5 minus x is the same as negative 1 times x minus 5. Just a little note, for that. You won't need to know that just yet, but just know that that is some information that's coming. Okay, so on this example, we have 12t to the fifth plus 6t. And so we're going to pull out, let's see, I know there's a 6t here and a 6t here. So 6t, then what do we multiply 6t by to get negative 12t to the fifth? That would be negative 2t to the fourth. What do I multiply 6t by to get 6t? That is 1. Okay, this is just like one of the ones we just looked at. Here is a common binomial. So we're going to pull out d plus 2, and then we multiply that by this coefficient and that, 4d plus 9. Okay, this one has a lot of different terms in it. So I think what I'm going to do is just go, all right, I'll factor this part out first, and then I'll factor this part out first. Because I see that there's not an x in everything. There is no other greatest common factor. So for this part, I think I will pull out x squared. What would I multiply x squared by to get 2x cubed? It would be just 2x. What would I multiply x squared by to get 5x squared? And that would be plus 5. Oh, look what I have here. It's a common binomial. So I will just pull out 2x plus 5 and multiply that by x squared plus what's really here that we don't write? Plus 1. Okay, this one is, we're almost done, x to the fourth minus 12x squared. So my common factor is 4x. What's the lowest exponent on the x's? A square. And so what would I multiply 4x squared to get 8x to the fourth? 2x squared. And then, what do I multiply 4x squared by to get negative 12x squared? Negative 3. All right, and then last example. Oh, no, not quite the last example. Next to last. Last but not least. 12ab cubed plus 20b. So the only variable I see is a b in both of these. So negative 12 and 20, the greatest common factor is going to be 4. And then a b, and the lowest exponent on the b is a 1, so I'll just leave it like that. So then this would be negative 3, and that would get me negative 12. And then an a, and then a b, you guessed it, squared. And then over here, what do I multiply 4b by to get 20b? Just a 5. And then, finally, our last example of the day is the greatest common factor in all of these. I don't see a common variable in all of them, but I'm just going to go with 2. And then I would multiply this. 8m squared will give me 16m squared minus, I just need an n cubed right here. And then right here, I'm just going to need a 15m. And that brings us to the end of this video.